Okay, hello, assalamu alaikum, guys. So in previous lecture, what we did was radioactive elements or radioactive rays we have studied. Now we'll be studying, the characteristic of death, alpha, beta, and gamma. We discovered in the previous video. Now we'll be discussing their characteristics. So as we know, this is a lead covering because they'll be emitting radiations. Okay, so means to stop the radioactive rays from moving outside, we are using lead here. So here's a coating is there which is known as lead or PB. Okay, so when the ray, okay, here's a hole and the rays are coming. Okay, the single ray is coming. So let's discuss. So basically alpha is having more mass, so simply it decreases. Here's the map. For example, we are taking here two poles, south pole and north pole. Sorry, north pole and south pole, you can say. We have studied that north pole attracts heavy masses particles. So now the positive is attracted because it is having high mass. After that, the beta rays, these are negative and these are having mass. So that's why they fall down. And on the last, gamma rays, they have no mass, they are energy, they are photons. Now you'll ask, what are photons? Packets of energy. You have studied in the previous classes, I hope. Okay, so now let's just start. This was a basic, we also did in previous videos, but now I was just reminding you. Okay, so let's just talk about first mass. So alpha rays, alpha rays having high mass. Like here it bends earlier from beta and gamma, so it's having high mass. So here we have written higher mass, and beta rays, it was second to fall down, so lower mass, and gamma rays no mass, we know. Okay, charges. So remember one this code, man. I have invented it myself, but it will help you. Okay, mass is directly proportional to q, means whenever mass will increase, charge will increase. Okay, first thing. So alpha is having more mass, so it's having high charge, and beta is having on number 2 high mass, so it is having high charge on number 2. It is having no charge because it is having no mass. Okay, and the same relation is, whenever the mass increases, the velocity decreases and the energy also decreases. Remember this point, remember. Okay, the velocity. Now the here we have means uh, covered a simple air box. Okay, so whenever mass increases, velocity decreases. So here alpha is having high mass, so that's why it's having low velocity. How much? The 10th part of light, in which light travels. 3 into 10 power 8 light travels. If I divide 3 into 10 power 8 by 10, so whatever will come uh, with this velocity, light no, alpha rays travel. After that, beta rays, it's having low mass than alpha, so it travels almost equal to the light, nearly equal to the light. Okay, so gamma is having just energy, and energy is light, so it is equal to light. Okay, now penetration. Okay, I was having low space, that's why. PP, penetration power. Okay, so it is having low penetration, which alpha is, because it is having mass. Whenever, means just imagine if a particle is heavy and it's moving towards a wall, it will not cross the wall. Just imagine Okay, close your eyes and imagine there's a wall in front of you, and you are you are doing bombardment of particles. Now, alpha particle is having mass; it will not cross the wall because it is having mass, and if there is a mass, there is a low velocity. If there is a low velocity, means the momentum is low, and because of the low momentum, low energy, it will not penetrate. But on the second number, beta rays, so beta rays is having high penetration. Okay, because it's having low mass than beta rays. Okay, and the third is gamma rays. It's energy, it's not a particle. It will move, it will easily move towards the wall because energy can move. Okay, ionization. Now let's discuss ionization here. Okay, so let's just see, like here's a ordinary any element or any atom. So here's an electron. Whenever we means do bombardment of alpha rays on any particle, so here's electron, alpha rays will go easily, means it will not go, but just attract the electron because it is having double positive and it is electron are negative, so it will attract towards itself. So what's the point? Ionization is highest in alpha rays because these are attraction. It is having double positive, it's having single, so it easily, like there's a fat boy and there's a thin okay thin boy. So whenever fatty boy can easily pull him. Okay, are you understanding? This was simple example. Okay, the second is beta rays. So beta rays is having negative charge. Whenever means beta rays will travel through electron, but it is having negative and it is having negative, so directly they will repulse themselves, means there will be repulsion. Okay, so on second number, that's why the higher ionization power is higher in beta rays, and the gamma rays last. Whenever we throw gamma rays on electron absorb the energy because it's energy. Gamma rays are energy, so electron means store the energy, and after some time it will change from one shell to another shell. That's excited mode. Now the electron is excited. Okay, after some time it will release energy and it will come to its original position, and that is known as de-excited. De-excited. Understanding what I'm saying? Okay, it will absorb energy and it will be in like excited mode and leave shell and will move towards the upper shell. But after some time it will release the energy means in a form of photons, and it will come to its original place. Okay, so so that's why it is having like lower, it is having lower sorry, it is having lower ionization, means just absorbing energy, not doing anything. Okay, it's not means like removing the electron. Okay, or you can say ejection of electron or break. This is known as ionization. Okay. Okay, after that there is wavelength. Now let's discuss wavelength. I know you have studied in metric class, if you remember, but I'm just not saying anything was means reminding you. Okay. Okay, so the distance between two consecutive crusts is known as wavelength, and wavelength is denoted by lambda. Okay, understand? So we know that whenever in energy there is short wavelength, because the particles are moving faster. But in alpha rays, let's see, alpha rays is having high mass, and because of high mass the velocity is low, and the velocity is low, it means it is making like large crust and large trough. Okay, so it is having high wavelength. Here is it written what? High wavelength. The second is higher wavelength, means beta rays, because it is on the second number, the highest, and the number third is gamma rays. Gamma rays, we know that its energy, it will move with the high velocity, with the high energy, and with the, because of that high velocity, it will make a small wavelength and move faster. Okay, so last is frequency. What's the formula of frequency? Lambda upon t. So whenever the wavelength is high, the frequency will be low, because it is making small uh, s- uh, wavelength. Okay, so on second number it's like beta rays. It will be having higher, because it is having less mass. And on the third it's like gamma rays. Gamma rays will move very fast, like energy is having high frequency, that's why it's having high frequency. So these are last point. Electron will become excited when gamma rays will emit or enter. We have talked previously. X-rays is wave in nature. 1 minute, I think I have something. Okay, alpha rays are waves in nature, because they are energy, and energy moves 1 minute, yeah. Energy moves in energy. Yeah, what I was saying. Energy moves in waves, in the form of waves. Einstein theory, or you can say Max Planck theory. Okay, frequency, number of waves in per second. We know wave number, or waves per length, means if there are 100 consecutive crust and 100 consecutive trough, we can say simple, we have 100 waves. Okay, frequency unit hertz. Ionization, when radiations collide with atoms, that can change the atom to lose electron. In this situation we are losing electron, we know this thing. But in gamma rays we are not losing, just we was absorbing, and after some time getting into original place. That's why the in the ionization it was having low. Okay, so I hope you have understand, sorry, understand the lecture. We'll be meeting in the next lecture. For now, Allah Hafiz.